Okay, let us now talk about the energies involved in electric current. Okay, so remember, inside this battery there are chemical processes that happen such that the negative terminal does work on a positive test charge to move it from positive terminal to negative terminal. And when it goes to this side, when it goes out immediately out of the battery, it now has a high potential energy. For example, this battery is 1.5 volts. Remember, what does 1.5 volt mean? 1.5 volts mean one charge carries how much energy? 1.5 joules of energy. Okay, so this charge now carries how much? 1.5 joules of energy. Okay, and then what will this charge do with the energy that it carries? Remember, an electric circuit is actually a device that will transform energy to other forms. Basically, here we have electrical energy. So this charge right now is carrying 1.5 joules of energy. And this 1.5 joules of electrical energy, once it goes to the lamp, will be converted into light energy. Okay, so remember that an electric circuit is actually a device that transforms electrical energy into other forms of energy that will be useful for us. Example is this lamp. And so if we are talking about energies, remember the battery has done work on a charge. And when that battery has done work on the charge will gain energy. And then if we talk about the rate at which this energy is distributed or being used up, we are actually talking about power. Remember the definition of power? It's the change of energy per unit time. Okay, and what's the SI unit for power? So remember, SI unit for energy is joule. So 1 joules per second is equal to 1 watt. Okay, so when we're talking about electrical energy, power is the work done on charge per unit time, or it can also mean energy used by load per unit time. Who will use this energy? The load. What is this load? It's either a lamp, a buzzer, or any other electrical device. So this is how we define power in terms of electrical energy. And this is the general definition of power: change in energy per unit time. But in terms of electric currents, let us derive the formula for that. Okay, so this is the formula for power, change in energy per unit time. This is the formula for current. Current is the amount of charge that flows through a cross-sectional area per unit time. And then potential difference, or change in voltage, or potential difference, is the change in potential energy per unit charge. Okay? How do we do this? We can rearrange this formula so that we can get the formula for the change in energy. I'll just use change in energy instead of change in PE. So this will become change in PE is equal to change in V, or potential difference, times charge. Okay, and this we will substitute it to this formula. So this will become P is equal to potential difference times Q, coming from here, over, do not forget this, over time. And what can we notice? Q over T is just equivalent to current. So, if we are going to use, if we're going to talk about change in energy per unit time in terms of electric current or electric circuits, our formula will be power is equal to potential difference times current. What is the SI unit for power? Watt. SI unit for voltage or potential difference is volts. SI unit for current is ampere.